Okay, everyone. So in this lecture, we are going to talk about closure inside a Python. So what is closure? For what purposes we are going to use closure? And we'll try to understand this entire things with the help of detailed example, by the way, one by one. So let me share my screen and let's start creating a file first of all for a closure, and then we are going to start with the lecture. So here I'm going to create a file closures closure.ipynb. Okay, now so let's try to understand what is this closure and why we are going to use it. So guys, see, closure is a type of the function or a type of the, you can say, like a entity you will be able to create, which is going to remember something for you. So which will be able to remember some of the values for you. So even if the execution of that entity has finished, still it will try to remember some of the values. For example, I will try to give you the example, and with the help of example, so we are going to start this one. So here, let's suppose I'm going to create a function. So there is an outer function I'm going to create. Now, so what this outer function is trying to do, so let's suppose inside this outer function, I'm trying to keep x is equal to 10. Okay. Now, I'm going to create an inner function. And now here, so I'm going to print basically x. So x I'm going to print, and then I'm going to basically return what? So I'm going to return a inner function. So as you can see in this particular situation that I'm trying to create a function inside a function, right guys? So here, what I'm trying to do is, so I'm trying to create a function inside a function. So there is an outer function and then there is an inner function. This inner function I have created inside this outer function. So nested function you can say, or function inside a function I'm trying to create in this particular place. Okay, that's great. Now the major part over here is with respect to a closure that we are trying to declare one variable called as x. And this variable is a part of which function? Obviously outer function, right? It's outside inner function. So obviously this variable is a part of what? This variable is a part of outer function. Now this variable I'm trying to use inside inner function. Fine. So I'm trying to use inside inner function. Okay. So now let me execute this one, and then I will try to give you the explanation about a closure. So here, if I'm going to call maybe like a closure closure, I'm going to write that as a closure, right? And closure is equals to outer. So if I'm going to call outer function, so okay, so this is going to execute an outer function, and it is going to store a object inside a variable that I have created, the closure variable I have created. Now what this closure variable is telling me, that there is an outer function, inside that there is an inner function, right? There is an inner function. And when I have executed this outer function, as you can see, when I have executed this outer function, so obviously I'm trying to execute whatever is there inside this outer function, right? So even I have like a variable x is equal to 10 inside this outer function. So I'm trying to execute that. And now when I'm going to call closure as a function, so it is going to print it. Yeah, it is going to basically print it. If I'm going to call closure as an object, simple like an object, so it is telling me that there is an inner function. But here, so you will be able to see that when I'm trying to call closure, this variable, you can name this variable as anything, my name, your name, that's completely fine. Yeah. So when I'm trying to call this entire closure, so you will be able to find out that this is executing the inner function, and inner function is trying to use what? Inner function is trying to use basically x. Now, so x is technically a part of outer function. Yeah. So if you will try to focus on x, so x is technically not a part of inner function. X is something which I have already declared inside a outer function. But here, so when I'm trying to call this inner function with the help of this one, a closure, right? Still it is able to remember that what I have declared inside a outer function. Now that thing that we are trying to remember is called as closure. Yeah, it's called as closure. So whenever you are going to create a closure, you have to make sure that there should be a nested function. There should be a function inside a function and in an outer function. So you are going to declare something so that your inner function is going to use it. That your inner function is going to use it as many times as it wants. Okay, now here, so let's suppose I'm going to create a multiple inner function. Yeah. So multiple inner function. So inner like then one I'm going to create, and then maybe I'm going to create like a inner two over here. Inner two over here. Let's suppose inner two, And yeah, so I'm going to return basically inner like 1, and then I'm going to return basically inner 2. It's completely fine, it is going to work. So I'm going to create a closer just as a variable, right? It's just a variable. So for the outer, yes, outer. And then if I'm going to call closer, you will be able to find out that there are 3 functions which has been created over here, right? So there is something called as inner 1, there is something called as inner 2, there is something called as, so inner 1 and inner 2. Now if I'm going to call this closer, right? So if I'm going to call this closer, so it is telling me that a tuple object is not callable. Yeah, it is telling me that tuple object is not callable. But here, so if I have shown you this part, so here I'm able to see, right? I'm able to see basically 3 different inner functions, so which I have created inside the outer function. So how I will be able to call this inner 1 or 2 or just a inner? So if I have to call this entire inner function, so one by one, as we know, it's a part of like a tuple. So I think we know the indexing operation, and with the help of indexing operation, I will be able to call it. Yeah. So closure. So E was missing. Fine. So closure of 0, inner 1, closure of like 1. So inner 1, by the way, and closure of 2. So it is going to give me what? Inner 2. Inner 2. Simple, right? And then if I have to execute the function, so call it as a function, then call it as a function over here. Simple. So in this way, I am able to call it. But one thing which is pretty much common across all of these functions, that all of this function was using x, and x was a part of outer function. So outer function is able to remember something even after the completion of an execution of my inner function. So outer function is able to remember something, and I'm able to use that one. Yeah. And I'm able to use it inside my inner 1, inner 2, or simple inner function. So this is the meaning of a closure. This is actually called as, this phenomena is actually called as closure. Hope all of you are able to understand that what is the actual meaning of a closure. Yeah, what is the actual meaning of a closure? Okay, now so I'm going to show you a closure operation with respect to a counter. So let's try to understand a closure operation with respect to a counter. So here I'm going to create one outer function called as counter function. Yeah. So I have one outer function called as counter function, and I'm going to create a variable called as count is equal to 0, right? So which is a part of what? Which is a part of my counter function, which is my outer function, right? Now inside that I'm going to create basically a inner function. So by the name increment, increment. Yeah. Increment. Now, so what this increment is going to do? So here I'm going to write like a non-local, right? Non-local, and then count in this particular place. And then I'm going to write count is equals to count. So plus whatever the value of count as of now is, and then return what? So return basically count over here. So retu rn return, and return what? So return basically a count over here. Yeah. And then so as a part of this counter function, so return the entire function. So return the increment function, as simple as that. Okay, so here if I'm going to call the outer function, so let's suppose c is equals to counter, which is the outer function, right? So which is the outer function. Now if I'm going to call c, right? So 1. Now if I'm going to call c, so it's 2. So if I'm going to call c, so it's basically 3. Now, as you can see that if I'm trying to call C again, yeah, C again, so you will be able to find out that with the help of, right, with the help of inner function, I'm trying to retain some of the thing, or I'm able to update something which is available inside the outer function. So which is pretty much amazing. Okay, so let's try to understand that what actually like what is exactly happening over here, and why we are using a non-local in this particular place, and then how we are trying to create a closure, by the way. So obviously I'm trying to create a closure with the help of increment. So I'm going to call like a 1 by 1 c, so which is eventually calling an increment, which is by closure, which is trying to like get something from the outer function. Now here, so as you can see, this is my outer function. So inside that there is a variable. Yeah, there is a variable. Now here, so I'm trying to call the same variable. I'm trying to define that as a non-local. What is the meaning of this non-local, by the way? So non-local variable, so what it will do is, so it will try to give a property, or it will try to help this count to update itself with a nearest possible variables. Means whenever you are going to increase the count, so we are incrementing a count here in my outer function, the immediate outer function that we have. So over there, if this variable is available, so try to increment the count. Yeah, try to increment the count. And because of that, each and every time when I'm trying to call this one, I'm able to get basically a incremented value of the count. This is the meaning of a non-local. Let's suppose if I'm not going to use non-local, then what is going to happen? So if I'm going to like remove a non-local from here, right? And if I'm going to write count is equals to count plus 1. Now here, so let's suppose if I'm going to call maybe d is equals to counter. Yeah, d is equals to counter. And then if I'm going to call d as a function, so if I'm going to call d as a function, so here it is telling me that cannot access a local variable count where it is not associated with a value. This is the error, guys, that you all are going to get if I'm not going to give a non-local. So it is simply telling me that cannot access the local variable count where it is not associated with the value. So here it will not be able to access this particular variable. As you can see, this variable is not the highlighted one, right? This variable is not the highlighted one. So it simply means that it is not able to access it. Okay, fine. So hope all of these things is clear. Let me give you a couple of more example with the explanation of a closure so that you will be able to understand closure in a little bit like a better way. Yeah, little better way. So let me give you a couple of example, guys. So counter example is fine. Now, so maybe I can try to give you one more example. So power function generator example. Yeah. So let me write down a code. So def power underscore of, let's suppose n, I'm going to pass. And this is the outer function. So one is the outer function. Then inner function is basically a power. So inner function is power. I'm going to pass x over here and then return x to the power n. Yeah, return x to the power n, and then finally return what? So return basically a power function, the internal one, power, power, the internal function. Just try to return this one. Okay, so we have an outer function and then we have an inner function, as we can see, and the outer function is trying to return the inner function, and outer function is trying to like take some input n, and inner function is trying to take some sort of an input called as x. Eventually inner function is returning x to the power n. Simple, right? Okay, now here, so I'm going to like call one variable square square. Okay, and then I'm going to call this power of, and then I'm going to call power of 2. Means a value of n which I'm trying to like give over here is equals to 2. And here qub maybe, so, or cub I can write. And then I can try to call a power of over here, and here I can try to write 3. Now here I can try to like cube, then quad, let's suppose I'm going to create, and then power of, and then I'm going to give as a 4. So value of n is equals to 2, value of n is equal to 3, value of n is equal to 4 I'm trying to give. Yeah, value of n is equal to 4 I'm trying to give. Simple. So value of n is equal to 2, value of n is equal to 3, value of n is equal to 4. Now this function I can try to use even to find out the square, even to find out the cube of something, or even to find out the to the power 4 of something. How? Simple. So if I have to find out the square 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 of something, so I can try to write what? I can try to write basically 4 square. Fine, 16, right? So the only reason is that it is able to create a closure, right? Closure function, and it is able to remember that what I'm trying to pass, right? So if I'm trying to call a square, so it is able to remember that what I have passed basically. So what is the value of n? If I'm going to call q, it remembers that what I have passed. If I'm going to call this quad, so it is going to remember that what I have passed basically. And because of that, so it is able to give me all of this output. So here we have a cube, and maybe I can, if I'm looking for a cube of maybe 5, I can get the cube of 5. If I'm looking for maybe a quad, so quad of basically like 6, I can get the quad of 6. So 6 into 6 into 6 into 6 is 1296 basically. So I'm able to get it easily. So here again, I'm trying to create a closer function, as you can see. And with the help of closer, I'm able to remember that what I have passed to the outer function. And then I'm trying to use the same. So this is again another example of a closer, guys. So hope all of you are able to understand and all of you will be able to write a closer right as per the requirement. So with that, thank you so much everyone. Take care. See you again in my next lecture.